Welcome to solverfy.
So the problem we are solving today is, let d be a positive integer. Show that among any group of d plus 1 integers, there are 2 with exactly the same remainder when they are divided by d, and this group does not have to be consecutive. So let's think a little bit about remainders. Consider another integer x, and what happens when we divide x by our given integer d. If x is a multiple of d, the remainder would be 0. Our other possible remainders, we could have a remainder of 1, maybe there's a remainder of 2, maybe there's a remainder of 3, so on, all the way up to d minus 1. Because notice that if we had d, like d left over, then we could just divide again and then we would be back at remainder 0. So these are all of the different remainders that we could have. And let's say that this is a set. So we have this set here. We'll go ahead and call it S. What is the size of our set S? So the size of our set S is D, because it's from 1 up to D minus 1, and then plus 1 for 0. So our size of this set here is D. And so this is going to be our pigeonholes in this example. We are going to be using the pigeonhole principle to solve this. So drawing out our pigeonholes, hypothetically, as squares, so there's going to be D of those. So these different remainders are the different buckets that we could fall into, or the different pigeonholes that we could fall into. And so now our pigeons are going to be the numbers, the size of our group of numbers, which we have been given is D plus 1. And so notice that if we have D plus 1 pigeons, so our size, okay, let's see here. So the size of the group which we were given at the start, we're going to go ahead and call it G. So the group that we were given in the problem, which is a not necessarily consecutive group of D plus 1 integers. So the size of this group G is D plus 1. And so this group represents our pigeons. And so if we have D plus 1 pigeons fitting into D pigeonholes, which we have from the size S, by the pigeonhole principle, we know that there must be at least one, or exactly one, of this from this group G, which falls into the same pigeonhole as something else by the pigeonhole principle. And so because of that, we